I'll post it on YouTube. So good to have you back again as we continue just to finish up where we ended. We found the deceleration. From there, we can now calculate the velocity just after impact. So we can find in equation 1, we can manage to find this one. If we can manage to find this one, then we can manage to find this one as well, because this one is actually what they're asking for in the question. So what I'm giving you here, again, as I always say, are skills of analysis, of saying, this is the information that I've been given. How do I build, how do I get from this information to where they want me, or what to get the answer that they want me? So they were asking for the velocity, as we saw. They were asking for find the approximate speed of car 2 just before collision. Now, how do we do that? We first applied the momentum equation and came up with this equation here. After that, we said, okay, since we've been given the friction force in the question, we can use that friction force to find the deceleration. If I find my deceleration, I can use the velocity. This is one of the motion equations. And knowing that, since I know that my velocity at the end of the day, my final velocity will come to rest, that is way after collision. Like after impact, there will be a certain velocity, but that velocity will start reducing because of this deceleration. So after impact, the velocity will start reducing with this deceleration. And we see that, just a moment, my screen stopped sharing. Okay, let me share again. So yeah, that's what we are saying, that using this deceleration, we can find the velocity just after impact. So we know that after impact, the car skidded for 6 meters, the two cars, so we have the distance covered, 6 meters, deceleration, negative 6.8, negative 8.6, and we know that the final velocity was 0. So we can take the initial velocity on the other side and becomes a minus. And then solving for this u, we see that u gives us 9.073 meters per second. All right. So we have been able to find u using this equation, knowing that this one will be 0. Acceleration was negative, we put a negative. And then when we took this one, the other side became a negative. We have found this velocity. So this is the velocity of both cars after impact. This is this velocity. After impact, when impact it just happened, it started decelerating. Yes, yes.
I'm back now. What is this u?
Huh? U?
What is u?
No.
Yeah.
I'm sure you know the equations of motion, right? That u, v squared is equal to u squared plus 2as. You know this equation, right?
Yes.
So this is just, we have just used it. U is just the initial velocity at a certain point. Now here we want to find just after impact, meaning after the impact, we want to find that velocity after impact, so that after impact, the two cars started decelerating at this rate, and then finally stopped, because at the end of the day, they stopped after covering 6 meters. So this u is just an initial velocity that we have picked to say, okay, from this point after impact, our initial velocity after impact will be this final. So here we have put it as final velocity, but here it will be our initial velocity because we are dealing with after impact. This equation is before impact. This is before impact, after impact. So here you find that the initial velocity is this one. But after impact, we had this velocity. But even after impact had happened, after some time, we discovered that there was acceleration that was taking place at this rate to bring the two cars to zero velocity. So that's how come this U now is the velocity after impact, which was acted upon by this deceleration to bring about the stopping. Is that okay?
Yes.
Okay. So, meaning we have found this velocity after impact, which is the same as this one. Then, for us to find what the question is asking, find the appropriate speed for car 2 just before collision took place. We see that once we have found this one, we can find velocity before impact. Find the approximate speed of car 2 just before collision. So, solving on, we are saying, remember this equation, meaning that for us to find the initial velocity of car 2, which is actually what the question is asking for, we use the above equation and replace VF with the value that we have just from finding this value. So solving this, we get this 2 velocity of car 2 initial is equals to 2, where there's VF, we put this velocity which we have just from finding, and then we can find the velocity of car 2 before collision. Is that okay? Are we okay with the explanation?
Sir.
Mm-hmm.
So here, does it mean that we're supposed to come up with 2 equations or maybe it's just one?
We came up with 2 equations. Okay. We came up actually with one equation, which was having 2 unknowns. We don't know this one, we don't know this one. So we used another equation to find this one. All right, we actually have used many equations. We used this equation, and then we also use this equation. We have used 1 equation, 2 equation, and the 3rd equation. The reason why we didn't call this one equation 2 is because this equation, we solved it. Everything we solved. When an equation is solved, we don't even name it as equation what is, because we solved everything. We found A, what we're looking for. Even in this equation, we didn't call it equation 3, because we solved for everything. We found the initial velocity, what we're looking for. So only this one did we label because we didn't solve it. We didn't know, we didn't find what we're looking for. Only here now, we have found what we're looking for by replacing the values that we have calculated using the other formulas. Is that okay?
Yes.
So, if we are fine with the solving, then I guess we can end here today. But I wanted even to show you how you could have gone about the question that was there in the test. But again, I think what I'll do is I'll just send you the document so that you go through the solution, because it is clearly defined. So this is the question that you had in the test. I've actually solved it here. so that you can actually test yourself and see what the question was actually trying to, how to go about such a question. So actually, I discovered that in the test, there was an error in the typing, because it is indeed Bob B which they were asking for some of you guys who attempted the test. Anyway, when you read through, you discover that everything is clearly and simple and straightforward, because I've been explaining, I've shown even the diagram, I've even explained how to go about solving this question which came in the test. Because of time, I will need you to go through it alone and make sure that you get the concept. But again, we have a homework. The homework, I would like you to solve question 2 in the tutorial sheet. If you read through your tutorial sheet, this is the question 2. I'd like you to solve it. So that will be your homework. Yeah. Are we okay with today's lesson?
Yes, sir.
Yes, sir.
Okay. Okay, Eunice, what are you saying?
Kindly go back there where we're finding friction.
Okay. Just a moment.
Okay.
Yes, here.
Yes, here normal is mg multiplied by mu. Then why is it that even here we have it?
Why is it that what?
Friction, since friction, our formula is normal multiplied by mu, and then for normal we have mg multiplied by mu. Then why after an equal sign here again we have mg and mu? I missed something here.
Yes, normal is normal is mg. This is normal is mg, is what we have here, and this mu is what we have there.
Oh, so this is what we have this other side.
Yes, normal is mg, because we are saying normal is just.
I saw the way we've cancelled here, where we have 2mg multiplied by mu is equals to mg. Is this mg or ma?
Yes, it's ma. Sorry, here it's hard to wrap, but anyway, I'll send it properly without this thing writing on it. Here, what we have written as 2, because there are 2 masses combined, mg. This is the normal times mu, friction force. We are saying friction force is equal to ma. Now 2, because there are 2 masses, all right? Now this mu will not appear on the other side, because this is on the side where there's friction force, and this is on the side where there's mass times acceleration. This is not mg, this is ma, 2ma, the a that we have actually found here, the a.
Oh, okay.
You are okay now?
Not really.
What is your question?
Sir, I'm saying the formula for friction. It's this is normal multiplied by mu, right? Now, is it okay? Let's just end from here now. For okay, like from F is equals to n mu without this equal sign, and then this n, it means that for normal we have mg multiplied by mu. Now my question is that.
Now that's where you are getting it wrong. Normal is not mg multiplied by mu. Normal is not mg multiplied by mu. Normal is if you have mass here. If this is mass is exerting a weight, which is mg, all right? Mg. Normal force will also be exerting an equal but opposite also of mg. That is our Normal. Normal is not mg multiplied by mu. Normal is just mg. Normal is just mg. Are you okay with that now?
Yes.
So, my friends, we are done with the class for today. I'm marking your test. Hopefully, some of you will even see your result by the end of the day. And yeah, have a good day. I think that's. I heard also Florence. You also had a question, Florence.
No.
Okay. Anyone with a question again, or we are okay? We are fine. Friends,
Yes, sir.
Mr. Wisdom, Eunice, Chipo, Gilbert, are we okay?
Yes, okay,
Yes.
sir.
Yes, sir.
Okay, so have a good day. This is where we end today.
Thank you.
The homework, so you need to solve it. Yeah, so have a good day.